Because what was your email? Can you put
It's MV24CEM 3R16, sir. Let me text you it once again.
NV24?
CEM.
Okay, just message me and I'll upload it.
Okay, sir.
So I can share this.
I kept it in the chat, sir.
Thank you. Let me know when we can start. Should we wait for another 5 minutes before we start? Or
Okay,
should
sir. We will wait until 10:10 and we'll start at 10:10.
Pardon me?
Another 3 minutes, sir, until 10:10. We can start at 10.
Yeah.
Okay, sir. We can start the session, I guess, sir. There are 20 people in the call.
All right, guys. Welcome. So, so Today, as I had promised, what we're going to do today is spend a little time on the. I went through cost functions yesterday, so I promised I will do some examples on the highway safety model. Correct. So we'll go through that today, and we'll try to see how we can make, yeah, we can do some interesting things with it. So let me open up my lecture notes. I've shared the lecture slides. Have they come through to you?
Just a minute, sir. I'll check.
Good
Yes,
morning.
sir. Received, sir.
Received. Okay. So now I'll just share my slides, but I also want to make sure that you have the slides from yesterday. Okay, good. Mm, here you are. So we'll do a quick recap of this thing, right? We'll just do a quick recap of how we do the models. All right. So this is generally a function of a safety performance functions. So the number of crash is an exponent of some constant plus 0.65 log of. So usually, what will happen is if you have a highway, right? If you have a simple highway, you'll only have one ADT. It can be ADT or AADT. So what you would do is you generally use one. Now, based on that, this would be your safety performance function, like your safety performance. So what this is nothing but equal to ADT raised to power 0.65. If just okay, let me just do this. If this is my formula, right? So my safety performance will be nothing but ADT raised to power 0.65. This will be my safety performance function. Okay. This is what a safety performance function is. It's telling you how will the number of crashes increase as the ADT is increasing. Okay. So that is the first thing which I want, just reminding you the concept there. Okay. The second thing is recognizing that there is over dispersion, right? So you have something called over dispersion because you have a negative binomial distribution. The crashes are over dispersed, and it's based on this formula, right? So we generally have, if the way you have the expected number of accident frequency is equal to the actual divided plus some with a weight. So this is the observed and this is the predicted. So you have to get a predicted value. So the predicted value would be just the ADT raised to power 0.65. Observed will be what you have observed. And the weights are based on this, right? So sigma is the over dispersion parameter. So these are two concepts which first concept I wanted to talk about. Then this is what the thing is, this is past by future, and you'll end up getting your crash modification factor from that ratio. NP future divided by P. Or NE with. Okay, so this is what we would get. So our first example is based purely on this. Okay. Did I open it up? No. So what we'll do is we'll do an example with 3 numerical sites, synthetic data again, and we'll do a SPF estimation as well using, I won't go through an entire model. It is, you can use data, you can use R. That's the best way to do it. But the whole purpose of this is not to teach you programming. It's to teach you how to interpret the models. We can, if you want, I'm happy to help you. You can send an email and we can discuss, but that is the first piece. And then how do you estimate CMF based on the SPF estimation? So we will go through an example. So this is the first example. All right. Now, one of the things we have done is we have a safety performance function. We for each of these for these sites, we have a safety performance functions. So based on that safety performance function, what we have identified is what is the predicted. So this is the before. So these are the before what we had observed. These are the number of crashes before, 3 years before. So there was 15. So there are 3 sites, 1, 2, and 3. So 3 years before, they had on site 1, they had 15. On 3 years before, in site 2, 12. On 3 years before, it was 20. So the total number of crashes here was 15 plus 12 observed crashes. 15 plus 12, 27, 47. Okay. Now, what we also know is that we have, based on the safety performance function, we have estimated a predicted value. So it was 13.5, 10, 18. So if you take this, you can't really use it. You have to basically use the idea of the empirical base. So the fact that you have an observed and you have a predicted, and you're going to put the weights on that. So the weights based on the over dispersion parameter, you have a K. So this will give you how much the mu b should be. The what should be the before. Okay. Any questions so far? All right. No, nothing to worry about. So basically mu b will be this W into YB plus 1 minus W into 13.5. So that is roughly around 13.79, right? So similarly, you have 10.5, 18.3125. So the sum of the before, you will get around 23 plus 18, 42. Roughly, it's around 42 or 43 crashes. Am I making sense so far?
Yes, sir.
Yeah.
Yes.
All right. So that's mu b. Okay. Now, similarly, I had the same, using the same safety performance function, I find my pi a, right? So that's the predicted values. Now, the ratios of these two is called G. So based on that, I can get what my expected. So if you remember this formula, let me go back. Remember, so we are basically using what should be the expected future, right? NE past divided by NP past multiplied by NP future. So what we have basically done is done NE past, right, divided by NP past. That is G. A model. Okay. So from that, I can estimate what my mu A is going to be. So you do that and you get your mu A. Now, let's go to the next slide. So this is what it's telling me. So YB is equal to 15, 12, 20. Pi B is 13.5. So you get all your pi's. So my crash modification factor, right, is basically the sum of YAs. So 9 plus 7 plus 11, that is 27, divided by mu A. So that's basically pi mu A, so which is going to be basically these. When you do that, when you do all of this, you get a crash modification factor of 0.61. So a crash modification. So we introduced a intervention, and we are able to, based on the before and after data, we are able to estimate what the crash modification factor would be. The key thing here, when you're estimating this is what empirical base is that you're accounting for the changes in the AADT, but also are accounting for the changes in the over dispersion. All right. Any questions?
No, sir. Good.
All right. The next thing I wanted to share is the synthetic data. So I shared a synthetic data set with you all. Let me here. So this synthetic data has several several variables. Okay, so this is a treated site. Treatment is active. How many crashes are there? You have an ADT, length, kilometers. So it's giving you the length, speed, shoulder width, access density, and all these this thing. So this is just a placeholder. This is pretty much constant. It's a 0.3 act. It's a part of a. Now we have an intervention which we have put. So some sites are treated. So those sites could have been treated before, and some could have been treated after. So basically what you're looking at is there a treatment there? Okay. So what we will be looking at is how do we estimate a crash modification factor and a safety performance function. Right. So if you're generally you have a data set which looks like this. It'll give you the year, 1, 2, 3. It'll give you the ADT. Usually you don't put year, period, all of this in the thing. You might put treatment, if there's a treatment or not. If the treatment is active or not, that's the other thing. You might have put it, but it might not be active. Like for instance, one treatment which might be active or not active is a dynamic message sign. So the dynamic message sign or a variable speed limit. So you have a speed limit, but the variable speed limit becomes active at certain times, but are not active at the other times. Okay. So we are going to compare what is the impact of this. So now let's go here.
Sorry, sir, I interrupt you. How we can know where the speed is impact will be on or not? Means,
Pardon me?
are you tell us that we are know the speed is impacted or not? So how we can realize that the speed is really impacted? Is what there will be any criteria na, to understand that point?
Can you tell me that again? I didn't understand the question.
Actually, you in treatment activity, you said that we can uh, catch up the speed. It is properly going or not. So how we can know the miss?
So it's called treatment active or not, right? How will we know this? So, okay, variable speed limit is an ITS thing, right? So usually it's ITS. So what is happening is the moment the way the variable speed limit works is that whenever there's congestion, the speed limit reduces, so it becomes active. Now that information you get at the traffic management center.
Okay.
So they're all electronically provided, whether the variable speed limit is on or not on. Make sense?
Yeah.
So usually you would either get the data, most of this data, if it is a ITS based system, you will get it through through an IT database, which is already set up. Otherwise, you'll have to do a manual, which is hard.
Yeah. Got it.
Okay.
So we generally place the sensor on that part, right?
Correct.
So, as well as the speed of vehicle is reduces.
Correct.
Right. Is okay. Got it.
Now, what I'm going to do is I'm going to fire up my Chat GPT, because we will use Chat GPT again to estimate a model. All right, so that then we can look at all the results from there. All right.
Yeah. Yes.
Give me 1 second. Losing you guys. Okay. Yeah. I'm not getting. I'm not able to share my screen. There's some issue. Saying in the Safari menu. Me too.
Once please check again, sir.
Okay. Yeah. Done. Yeah. All right. So what I did was this one is not it. I uploaded the data. So this is exactly the same data. Just uploaded it. You guys have you guys done it? Hello.
Sir, this can we do yesterday, na? Or days?
No,
Wednesday.
we did that for binary. We didn't use this data set. This is a day before yesterday. We did demand models. Remember?
Yeah.
So this is a different data set.
Okay.
So you upload that and say that. So and just type. Please estimate, or don't have to say please. Estimate safety performance, or you can also say SPF and CMF. Estimate safety, SPF and CMF using negative binomial and empirical base. All right, so you can put that in. So what I also did was very similar to the previous example. I created site specific. So for each of the site IDs, I've created a before observation, after observation, mu hat, W's, EV before and EV after. So what was the expected before and expected after? Right, so I have observed before this thing. So you can actually get expected after node treatment. So the site specific CMF, I can calculate exactly the way we did before. Yeah. So that's the one part. But even before that, what we really need to do is actually, where is it? Yeah. What we are going to do is we are going to be actually estimating a negative binomial model, right? A negative binomial model will include ADT, length, speed, shoulders, etc. All of these. So this don't worry about this. This is actually just for each of the different years, for the 6 years, it has created a dummy variable. So when you do that, it creates a coefficient. It creates a coefficient. And what you'll notice is most of the coefficients of this C year, right? Like the coefficients, the p-value is greater than 0.06, 0.05. So they are close to 0. So we don't really care about these variables, C year to this thing. We do care about the intercept. So the intercept is minus 7.03043. And the coefficient of this is log ADT 0.89545. All right. Let me open this in and let's open it with Excel. Actually, add Excel there. All right, so I have my ADT, okay? So what this basically says is that my safety performance function is equal to this ADT raised to the power 0.89545. Save it there. Just give me 2 seconds. I'm just going to copy paste now. And if I compare this to ADT, and we can, it's insert. No, this is giving me wrong. Should be. No, this is. This is basically, I think, yeah, that's good. So what it's basically saying is that for a given value of ADT, the safety performance function is telling you a little less. There's also, you have to also multiply this with another term, which is exponent of this constant. What was the constant? Minus 7.03. So this is basically the safety performance function is telling you that for each AEDT, what is the number of crashes that's going to be. And what you'll notice is that it is curving down a little bit. This is looking straight, but it's curving down. Okay. Because this is close to 1. But if I had made this, say, .59, you'll notice that it has got a lot more curve. So the safety performance function, that parameter, the coefficient of AEDT tells you how much it's curving and how much for any AEDT we should be expecting a given crash. Is it making sense so far? So this coefficient here is the safety performance function. So it's ADT raised to power ADT raised to power 0.89, and exponent of minus 7.03 will give you the safety performance function. So this and the constant are part of the safety performance function. Any questions so far?
No, sir. Okay.
All right. Then the next thing is you're going to notice that there are terms here, right? So the speed limit in kilometers per hour, the p-value is low, right? So that's almost close to 0. It doesn't matter. So it's not really affecting it. That the shoulder width is negative. So that means the greater the shoulder width, the accidents are going to low, but it is still not effective. Its p-value is greater than 0.05. But access density per kilometer has a significant p-value and it's positive. So what does this mean? What this basically is telling you that for a given access density, the CMF is going to increase. So the CMF is exponent of 0.09. All right. So that's basically how it's set up. So when you're doing your negative binomial GLM model, this is how you set up your model. And it tells you what the CMFs are for each of these. So if this had been, let's say if this had come out to be significant, exponent of 0.00696 would have been the crash modification factor multiplied by the speed. Yeah. Any questions on this?
So the model will be changed to variation of speed, or
Pardon me?
that if our speed of vehicle will be changed, the model, the final output will also change.
Also will change. Yes, of course. Yeah.
Means it is depends on our vehicular speed.
Yep. Any questions so far?
No, sir, I think.
Does this help you understand a bit more on how to use this? So if we go back in terms of what we have learned in the example so far, two things. One is if you have got data before and after, given SPF and the over dispersion factor, how do you estimate the crash modification factor? The second thing is, given a data, how do you estimate the crash modification factor?
Yeah, yes, sir.
Excellent. So what I'm finding really fascinating is how close a lot of the one of the places where generative AI is really helping out very well is coming up with code and being able to do these model estimations really quickly. But these were also very simple. So they help you develop very simple simple models, very quick and dirty models, right? And analyze it and all of that. But if you want to make more complicated models with comparisons and all, it will take a lot of time. You'll have to learn how to code.
Sorry, sir. Out of the question is in coding in Python. Can we, which type of library we are generally used for this type of data?
R. Usually we use R.
R. Okay. Okay, sir.
So that's all I have for this this part of the work. What I want to do now is we'll delve in. We'll go straight to the. So that's. Second, give me 1 second. I'm just going through. Yeah. Just what I want to do next is go into the public-private partnership piece of the analysis, if that works for you. And we'll try to go straight instead of taking a 15-minute break. What I'm thinking is we'll spend time and try to go through it and try to finish early, if that works. What do you all think? But if you feel like you need a break, then we can stop.
We go, sir. We go, sir.
Okay.
Okay, sir.
All right. So. So what we're going to talk about, and we'll talk about do some examples on this as well, right? So the first thing is we'll talk about PPPs, public-private partnerships, hybrid models, and transport projects. So what we talked about, let's go back to the purpose of this course. Let's go back to the objectives of this course. The course was around looking at transport economics for smart city projects and for smart transportation projects. All right. So the first thing, when we come to transport economics, most of our discussions so far, right, have been looking at how do we prioritize or how do we decide between different projects, correct? So the government has to spend $300 billion. How will it decide which one should go first and which one should not go? So how do you rank them, right? So that has been majority of the questions we have discussed. And we have done that across a wide range of activities, right? We have done safety, we have done economics, which includes GDP, etc. We have done logistics as well. Now, an important part of transport economics is public-private partnerships and hybrid models. Why? Why is that? So in everything we did before, we had the assumption that government has all the money and it can spend money for whatever it needs, right? And what we are trying to do is prioritize them and make sure that there's a cost benefit to cost ratio of greater than 1. If the benefit to cost ratio is less than 1, that means we should not be doing it altogether. So this part of the lecture is a bit of a fundamental shift in thinking, because what this talks about is more about financing. Will a particular model, if there are private people, will they be able to earn interest on that? Will they be able to get returns? When I say interest, it's not interest. Will they be able to get returns on their investment? Okay, so that is the fundamental question that we are trying to ask. And the analysis that is undertaken in this is quite significant, because there is quite a lot of due diligence and a lot of people's money is is on the hook. So the level of due diligence, the level of contracts are quite gnarly. So we're going to kind of actually talk through that, talk about different models, and do a small example on how to go about it. Any questions in your thinking or any assumptions which you would like me to? All right. So again, we're going to be first understanding the PPP fundamentals. So what does PPP stand for? Public-private partnerships. We're then going to talk about hybrid PPP models and review global case studies and identify best practices. The concept of best practices is every region has its own best practice, and every region, and that's because they have different risk appetite, they have different capital flow situation. There are a lot of differences in different regions. Just because hybrid annuity models or a type of PPP model works in India doesn't mean it will work in Indonesia. So that is fundamentally what I would like us to talk about. Any questions?
No, sir.
Okay. So what is PPP? So a PPP involves collaboration, and as the name suggests, it has public and private. So who's public? It's basically the government. The government will ensure that there's oversight and governance. What does oversight and governance means? Particularly when there's public infrastructure, right? And this public infrastructure, there's a big element of oversight, governance, legal frameworks that are taken care of. And where does the private sector come? The private sector comes putting in capital. They will say that, look, we know that roads need to be built, but the government today does not have a $20 billion road. So what we'll do is we'll take it to the bonds market. Right? So that is one piece which we want to kind of start looking at. So how does this work? And there are different parts of, so there are actually two things why the private sector comes in. One is they're providing capital because the government is wanting to get extra extra money. But the second thing is they take on the risk. So when you know that there is a particular infrastructure that is being built, but you don't know if there's going to be enough people or not taking that on, and will that infrastructure get serviced by the revenue that is going to be generated. The private sector is taking the risk of the revenue generation, right? So that is where the partnership works out. The private takes on risk and they're providing the capital. The public sector is giving oversight and governance around it, right? So usually, when does the PPP model start? PPP models don't start at the design and build phase. So the design and build is usually done by the government, because they will say that, look, we know that we need to build a road here. This is the design, this is the build. There is one model, it's called the Swiss challenge model. The Swiss challenge model is that the private sector comes sumo moto and says, we were going to build this road. All right. We will come and build a railway track. Lot of we will go and build a sugarcane railway track. So a lot of those can also come in, and that's where the private sector takes an enormous amount of risk. But where PPP model comes into play are basically when you're operating and maintaining, when you're trying to get financing for that thing, when you're design, build, finance, when you're design, finance, maintain, and full concession. There's another model which is called privatization. So when the infrastructure is privatized, right? Like a good example of privatization was the spectrum sale. When the government of India sold off telecom spectrum, right? Like 4G, 5G, 3G, 2G, the government did a bid and they privatized it. There are some of the hospitals that got privatized as well. So there is an aspect of privatization, and there is also places when there are infrastructure which are of national importance, they get taken over by the public. There's a government takeover as well by the public sector. So the place where PPP kind of sits, and based on the degree of risk, is when you take a concession, it's the biggest. When you're doing operation and maintenance, there's hardly any risk, because it's more like a contract. The government gives you a contract, and you're just operating and maintaining it, right? So usually the way these PPPs work is it is a special purpose vehicle which is essentially has investors, equity investors. You have investors, you have lenders, banks and all of that as well, who are providing debt, and you have to finance that debt as well, service that debt. How are you going to service the debt? By the revenue that infrastructure is going to generate. All right. But to build the road, to maintain it, you need a construction partner, a planning EPC contractor, and you need an O&M contractor, which is an operation and maintenance contractor. And this special purpose vehicle will sign a contract with the government, right? Now, the way it works is you can get a direct letter for some projects, or you can, and after you get that, you hand it back after 10 years, 50 years of concession. And what you're doing is you're getting the revenue. The revenue tends to service the debt, but also some of that revenue also goes to the government. So you can do a hybrid as well. And we'll talk in detail about that. Any questions so far and any thoughts?
Sir, in PPP, the revenue generation is splitting which criteria? Means how much percentage will be government and how much will be private sector? Because
I have exactly an example on that. So it is actually a very interesting problem. So you do a market sounding. So you don't, so there is a market sounding where you go with a proposition and you go and talk to different investors and different people on whether or not this is a agreeable contract or not. Will people bid for it?
Because sir, in Maharashtra, we are know the Mumbai-Pune Expressway is constructed on PPP mode. So
Correct.
currently it is on the private sector. The whole the toll revenue generation or the
It's
maintenance
going to the
are
private. Yeah.
private. So the already there will be how much they invested that road. They have already collected. Means how much amount they have spent or invested to the during the construction. But
Correct.
how many day they are required means to give the all the revenue to give to the private sector only.
Okay. Okay. So it all goes to the private sector, but there are some which are hybrid, and I think there are some examples of a hybrid annuity model as well. Yeah. Can you give me 2 seconds? I just need to have some water. So I've run out of water. Just give me 2 seconds, and I'll be back.
Okay, sir.
All right. Thank you. I'm back. Any questions so far? Um,
No, sir.
all right. Perfect. So as we discussed, right, the reason why PPPs have actually been explored is three reasons. One is large capital investments. When you have large capital investment needed, but that capital investment might not be available immediately in the hands of the government, or in the is not likely to be recognized in the what you call in the underlying budget, right? So like when the governments are doing budgets around tax revenue and all of that, they set aside some budgets for transport projects. So if there is not enough budget associated to that infrastructure or to that sector, then PPP models would make a lot of sense, where you need a large capital investment over and above what is budgeted, and you are also providing risk sharing. Now, there is an argument around the fact that private sector actually provides efficiency and innovation in design. So that is also found, right? Like so PPP projects tend to be more on time, more delivered on budget, and the reason for that is just because the sector, it's not like different divisions providing different the it is the people who are actually constructing, managing, are the people who are trying to make sure that the revenue is servicing the debt and the equity. Now, one of the things which you need to be very careful with PPPs is that because the private sector is playing a role, you need to have good checks and balances. For instance, any public infrastructure is there to service the public, the people, right? So what you need to be thinking about is how can we, so one way of actually servicing a road, like doing a PPP on a road and getting it serviced really quickly, is just keep increasing the tolls, right? But you can't, because it would undercut the publicness, undercut the publicness of the intent of publicness of that infrastructure. So there'll be checks and balances. So the checks and balances would be that you can't charge more than this much toll. You need to maintain the roads at this level. So for instance, you need to ensure that you can only have you can't have potholes for more than 2 days. It has to be. So there are these checks and balances that come in, so which actually improves efficiency, but you need to have that from a government perspective. So that goes into the contract. So I've put together all the types of PPP models that we are aware of. So there's operation and maintenance, which is basically the ownership is a public one, but it is a service contract, the private op. There's build and finance. So build and finance is the private sector builds and finances the construction, then hands it over to the public authority. And from that, it will, the government will be servicing that loan. All right, it will service it. Usually, this is not the most this is not, the build and finance is not are not used on our like for roads and all of that. They might be used for like buildings or small infrastructure, like a boat, if there's a boat, or yeah, it's basically like a lease. Build and finance is basically a lease model kind of thing. Build, operate, transfer, you all know about this. So that is, you build, operate for a concession period, and then transfer it. The next one is boot, which is build, own, operate, and transfer. So in build, operate, transfer, the ownership still is the government that owns it. So the build, the private sector design, builds, finances, operates, and maintains the asset transferred back after concession, but it is owned by the government. Boot is the most I think the most used model in India. There's also a hybrid one, but the build boot is the most used one. But the private entity owns works during concession and then seeks profits before transfer. Then you have BOO, which is you don't have the transfer, it is never transferred back. So usually telecom networks, water treatment plants, they're all BOO. BLT, which is basically airports. So this is build, lease, transfer. So you're basically leasing it from the government. Then you have design, build, finance, maintain. Design, build, finance, maintain, and operate. Design, build. So if you go back to this thing, you're now here. You're taking on the design part of it as well. Right? So you're starting to do low risk activities here as well. So the risk starts this thing. So these ones are higher risk. Any questions on this? So when you asked how do we decide which model we are going to take, what we end up doing is we look into all these options. What will be the cost? What will be the revenue? What will be where can we actually drive efficiencies, right? So one of the places which you're always trying to do is trying to see what innovation do you have so that you can reduce your cost and improve the outcome for your clients. Any questions? Now, as we talked about, when doing any of this, right, the private party usually creates a special purpose vehicle, which is an independent legal entity which can coordinate and create contracts. It manages the risks and manages the revenue. But it has a board of directors who are legally liable. They can go to jail if they go do something wrong. So the concept of a special purpose vehicle is an important one in these PPPs. Any questions? I know that it's not very mathematical. This is more the framework in how these things are going. But I'll show you how the economics plays out. But these are important part of what goes through this. The advantages and challenges. So the advantages are, of course, you're driving efficiency, you're having more innovative solutions, you're getting access to private funding. And the risk is not with the government, but it has now moved to the private entity. The challenges are around the governance, risk allocation, political risk. So when you're doing any of these PPPs, you generally want it to be backed. You're trying to manage the risk. You want it to be backed by sovereign funds or sovereign. So that it's called sovereign backed risk, sovereign backed funds. So what that means is that if this thing goes bankrupt, the government will buy it. So that sovereign risk is very, very important. So that's the reason why a lot of infrastructure is not built in countries where the politics is not stable. Right? So yeah, I think that's one piece which you want to be looking at is the political risk when you're doing a PPP project. Any questions? So when you're trying to manage these risks, one of the things is people have gone through the idea of hybrid PPPs. Now, hybrid, what is hybrid? Hybrid is basically so hybrid IPP, the hybrid PPPs are about actually managing the risks around the funding. So what usually they try to do is they will say that the government is going to provide 10% or 40% of the funds, and the rest are going to be raised by the market. Or the government is going to provide land for free, and the government is going to, and the private will raise the funds for doing the construction and operation and maintenance. So it's a mix of grants, tolls, and availability payments, right? So availability payments is also that what you are also saying is that I'll take the 200, we will, the government will give you a grant, but also you will have to pay some certain amount of money to the government every year. So that's availability payments. So it improves the bankability and affordability of the whole program. All right. So you have these you need to do very complicated economics to actually, not complicated, but very, it's not complicated. It is more in depth and very careful analysis to ensure that the banks can afford and the returns are suitable. So this is one example where you have a 40% grant and 60% user charge. You also can get concessional finance options or blended payment mechanisms where there's some payment being made every year by the government, but you're also paying part of the revenue to the government. Okay. So again, why hybrid PPPs? Addressing affordability concerns, encourages private participation because, why does it encourage? Because it reduces the risks. The private participation is increased because it reduces the risks. And it increases the viability in developing economies, particularly in developing economies. If it's a developed economy, like say Australia, some of the European countries or Japan, there is a lot of history and expectation around sovereign that the sovereign risk is low. Any questions so far?
No, sir.
So again, the best practices in hybrid PPPs are to ensure affordability, align incentives properly. When they talk about align incentives properly, associate the risks appropriately as well. Adapt to local capacity. So don't try to do stuff which is highly automated in a region which is very labor intensive. Right? Is there enough, even if you get a high quality milling and relaying the road machine, if you don't have the capacity to actually run it, then it again doesn't get used. And leverage concessional finance. One of the things where a lot of the PPPs have gone wrong have been in their initial assessment, right? When they're doing the forecasts and when they're doing their forecasts, they tend to be very optimistic about the number of people that are going to get on, use that facility. And also the second place where a lot of these roads go bust is the cost of maintenance. The cost of maintenance of those roads. Any questions? So again, but this is true for any such thing, that you need to understand the project, figure out the delivery model, structure the finance, allocate the risk, and contract the drafting oversight. So we'll do an example of this, okay? We'll just do an example of this. So this is the project overview. There's a project of 120-kilometer highway, total construction cost of 1,000 crores, okay? And a concession period of 15 years with a discount rate of 10% per annum. All right. Any questions on this? This is what it is. So the scenarios are the private developer. So we are going to do a BOT with toll. So the private developer finances 100% of the cost, right? So he's going to pay the 1,000, he or she are going to pay the 1,000 crores and recovers this through toll revenues, assuming an annual cash inflow of 120 crores. Now, this is where a lot of mistakes happen and PPPs go bust. Okay. And we'll talk about that. So the cash flow in the first year is minus 1,000 crores, right? That's done. So that's gone. And years 1 to 15, you're getting 120 crores a year. All right. We did an example of this on the I think the second day. So we know how to calculate this. Then we have something called a BOT annuity model, where the developer finances it 100% and the government pays a fixed annuity of an annual payment of 110 crores. So they'll provide 110 crores. So you're not putting a toll, but the government is paying you 110 crores every year. Okay. So that's an annuity model. And then there's a hybrid annuity model where the government pays 40%, that's 400 crores during construction in equal installments across the construction period, right? So 200 crores per year. And the developer finances it for the rest 60% through debt and equity. Okay, that's 600. And after completion, the government pays semi-annuity tolls of 85 crores per year. So you have 200 minus 200 plus 200. So we'll talk this thing. And you have the next 2 to 16 years, you're going to get 85 crores per year. So this is just going through an example. I think I have made a mistake here. Can anybody tell me what the mistake is? I just noticed this in my scenarios. Can somebody tell me what my mistake is?
No, sir.
So it should have been the other way around. So what's happening is, should I put it? I have not accounted for the 600 crores in debt. So I've done 400 crores are going in negative and 200 crores are coming from the government. Does that make sense? So I have made an error here. So yeah, so essentially, or have I? I'm just looking at it. This part should be, let's look at the private party puts minus 400. Oh yeah, it's fine. Sorry, this is fine. So this is minus 200 crores year 0. This makes sense. I confused myself. So the private party has put minus 400 and public has put plus 200. So that is equal to minus 200 crores, right? And then the next year, the private has put minus 200 crores. So that is 600 crores have been put in. And the government is giving another 200 crores. So there's net zero. That's how it has been set up. Does that make sense? So I was just trying to figure out where is just do this again for the second year. So that's how you get minus 200 plus 200 is equal to 0. This minus 200 is the minus 400 from the private plus the 200 that's coming from public. That's why it's minus 200 crores. All right. So that's the developer construction share. Any questions on that? And then for the next 15 years, you get 85 crores per year. So now we're going to compare these three models. All right, we're going to compare these three models. So the way we compare these three models is by looking at the net present value. So the net present value is minus 1,000 crores plus you're getting 120 every year for 15 years, right? So that is equal, that is this term here. We did this yesterday. Just give me 1 second, please. 1 second. let's take a 10-minute break and then I'll be back. We can be back. I'm sorry. There's just an emergency which I'm trying to take care of. So apologies. Let's take a- so we'll be back at in 10 minutes, 10, 15 minutes. Thanks.
Okay, sir. Thank you, sir.